Hey, all right. It is that time again. Hello, everyone. I'm John Park, and welcome to John Park's workshop right here on Adafruit in my workshop. It is so nice to have you here today. I hope you all had a very lovely 4th of July yesterday, particularly if you're American and celebrate Independence Day. But for everyone, I hope it was a very nice day that happened to be the 4th day of July. So I have all sorts of fun stuff in store today. Here's a precap. I don't know if that's a word, but here's a preview of what we're going to do. We're going to have a MakeCode Minute today. We're going to have a Product of the Week. We're going to have a Tool Tip. And we have a project. Now, the project is a little on the edge of what may or may not work well on video. As you can see from the title here, this is Stroboscopic Zoetrope. So we're going to be doing stuff that involves flashing lights. So 2 notes on that. 1, epilepsy warning. I don't think it'll be that bright on your screen, but if anyone is sensitive to strobing lights, there will be strobing lights on the show today. And the other issue is that sending anything that relies on specific timings of strobing can be tricky with video because there's a rate at which the device captures the event, as well as transmitting and broadcasting and all that stuff that goes on. So I think it'll work, but we're going to experiment a little bit today with some zoetrope, stroboscopic zoetrope, and it'll be a really fun thing for people to try out at home, which you'll be able to do easily. So hopefully at least this will serve as an inspiration today on ways that you can experience your own stroboscopy. It's probably not a word. But that does lead us to a word that I know is a word, and that word is today's coupon code. So today you get 10% off in the Adafruit store if you use the coupon code STROBE. Strobe. 10% off in the store. That is good until midnight, I think, tonight, West Coast time. And that'll get you 10% off of all goods that you can purchase in the Adafruit store, with the exception of gift certificates, subscriptions, and software. And someone asked about a box that I tweeted out the other day. Yeah, let's do a little, maybe a little semi-early reveal. Because you've tuned in here, I'm going to walk over to the corner, the secret corner of the workshop. And some people may have seen that I tweeted out a picture of a box that had a little something in the corner there. And, oh, this is 002 of 4,000. So I have 2 boxes early. And so that's enough of that. Let's put that away. But it is coming. It is on the verge of release, and I have a couple of the AdaBox 008s right here in the workshop so that I'll be able to put together some videos of the unboxing and the stuff you get inside. So I'll be working on that, and that's why I have those first 2 boxes off of the line. First 2. So there you go. I hope that satisfied your curiosity a little bit, Just the Daz, who asked over in the Discord chat. So there you go. That's your coupon code of the day. It'll get you 10% off in the store. Strobe. And hey, that leads us to Product of the Week. So the Product of the Week that I picked for today, for this week, is the TFT Featherwing 2.4 inch. And here's one right here. Let me hold that up so it doesn't shine. A reflection right back in your face. So this is a thin film transistor LCD display, which has a touch, resistive touch element in front of it so that you can enter XY coordinate presses into software. And it's a Featherwing. So here I've got an ESP82 or ESP8266 feather happens to have these long stacky headers on here, so I could stick something else on top, which makes it a bit of a pain to plug back in, so I won't right now. But this is the feather wing. It is very cool. Here's the picture of the backside for you. And I have used it for some display projects, particularly with wireless stuff, and I made a remote that used one of these as a display. I did a different remote using a little OLED for a small amount of text, but I had to do some color stuff that had to be larger, so I used this display, super cool display. And a feature that I've never used is it's got an SD card on it, so you can pull rastered graphics, I think BMP files, off of the card and onto the display, which is pretty cool. A little note about these displays, by the way. Oh, I have one here I can turn on, in fact. So here's one I built into a little project box. Let me flip the switch on. It has an on-off switch on it. That was the note I wanted to make. So there it is, booting up and running through a little bit of a demo. This is a default bit of demo code that we have available. If you go to the Learn Guide and check it out, you've got a couple of different pieces of sample code that you can run. And this goes through a pretty cool little graphics demo on here, so you can get an idea of what some programmatically generated graphics look like versus BMPs. It's a 320 by 240 display, so it's pretty high-ish density of pixels for the size. Text looks pretty nice on it. Let me hold that without glare. Oh, it doesn't want to focus. It looks better than that, I promise. And yeah, so that was the point I was trying to make is this has an on-off switch on it. That's, I believe, wired to the enable pin on the feather. And the first time you use one of these and it's in the off position and you forget that it exists, you think something has gone horribly wrong with your code. Well, not you, but me. This happened to me. I thought something had gone horribly wrong. I couldn't figure out why nothing was powering on until 20 minutes later I realized, oh yeah, there's a little on-off switch on here that enables the whole feather. So there it is. That's the product of the week. The super cool TFT display. There's also a larger one. There's a 3.5 inch, I believe, display. I haven't used it. It looks super cool. And given the speed of the new Feather M4, I imagine using CircuitPython with a Feather M4 and this display, or the 3.5 inch display, will be a really powerful setup for things. I have some interest in doing a display for my synthesizer that I built. Do you guys remember this little, here it is in my cardboard box, tying it back to cardboard. Here's my little DSP G1 based synthesizer that has a couple trellises in here. The little TFT display that we have runs off of SPI, so I think that means that it should be able to run on this, which is using I2C for the trellis stuff. So I think we've got the room for it, and maybe the processing power of the M4 to be able to maybe show some waveforms, at least if not the real waveforms that are running, kind of a preview of things, or give you some values as you change stuff. I don't know, but it could be fun, and that little display would kind of fit nicely in there. So we'll see. It could be a project for the future. All right, so that's the product of the week. And I notice in the chat that people have caught on to the fact that I'm evil because I'm showing you cool stuff, and that cool stuff costs money. I know, it's true. Brent says that here's a fun Adafruit fact. The default demo code that I just showed on this little guy right here is the demo code that runs in the factory when they are gone through testing, which is pretty cool. Yeah, it is pretty fast, and with the M4 it'll be super, super fast. So there you go, product of the week. And that brings us to, are you ready for this? I'm going to get a sip of iced tea first. Hold on. Get ready for it, because here comes the MakeCode minute. So, MakeCode Minute today, I want to show sort of two things. And I wasn't aware that this console simulator was working. So the first thing I want to show you has to do with the console simulator. So the console simulator is available in MakeCode. Oh, here goes a jet plane going by. This is available in MakeCode when I click on the console section in the advanced categories. So open up advanced, click on console, and then you just get these two options to log things, either text or a number, into the console. So I'm going to choose this log a value of X. And just to demo it, I'm going to throw that into my forever loop. So now it's going to bring up this show console simulator. I believe this was working in the standalone executable on Windows only for a while. I never got it working on Mac until just this morning. Or I was doing something wrong this whole time. But here it is. If I click on Show Simulator, I get a console, like a serial output down here at the bottom, which says X is 0. I believe this is ticks running by of the program. And then we'll also have a graph. If I head back here and let's just change the value. Let's just say make that 5 and show this. It's now gone up to 5. I think it restarted the graph. So what we're going to do is use this console as a way to look at this concept of incrementing or de-incrementing, if that's the right word for it, a value. And it's going to tie into the project today. So what I want to do is actually create a variable. And we'll just call this my foo. So I'm going to take a copy of set my foo and a copy of my foo. And now I'm going to map whatever the value of my foo is to that console. I'm going to start off with it, just for safety, actually having a value so nothing crashes or gets weird. So I'm going to duplicate this and say, let's initially set the value of foo to, how about 1. Now what I want to do is use a couple of button inputs to either increase or decrease the value of foo. So let's duplicate this to be a button B click. So now I have button A and button B. Right now they do the same thing. They set the value of foo to 0. Let's do a quick and easy version. We'll say left button goes to 5 and right button goes to 10. Okay, so let's simulate that. And now you can see it started off at 1, and then if I click on the A button in the simulated Circuit Playground Express here, the value just jumped up to 5, and so you see the graph step up from 1 to 5. Click it again and it jumped to 10 and back down to 5 and so on. So you can see the numbers are printing down here and the graph is graphing, which is really cool and very helpful. And one of the reasons I'm excited about this is it'll allow, I think, easier instrumentation of sensors. If you want to look at a value of a capacitive touch, what's the raw values that are coming out? This is the way you can do that easily. I hope that works. I haven't tried that yet. Okay, so I've lost my MakeCode window. Where'd you go? So now I want to use my buttons to increment those values up and down. And so the way I'm going to do that is create a little bit of math node here. So I'm going to, in the math section, grab a 0 plus 0 and drop that into each of the existing button nodes. So I'm going to set my foo to be equal to, what the left button will do is it'll be equal to foo itself minus some value. So that'll be the button that drops, let's say, your volume down or some number down. And the right button will use a plus to go up. So I'm going to go back to variables, grab a my foo variable, and I'm going to duplicate that. So when this program launches, the value is 1. Foo is set to 1. So if I click A, I'm going to say set the value of foo to whatever it currently is minus, and I'll just put 1. Then in the B button, in the case of the B button, I'm going to do the same thing, set my foo to be whatever my foo used to be plus 1. Okay, so let's simulate that now, see if I got that right. And now I'm going to click in the virtual A button, and you can see I'm subtracting 1 every time I press that. You can see my nice graph there showing me. If I click it faster, we get a denser curve. If I click it slowly, I can change the shape of that curve just for fun. And then the right button adds to it. So that, in and of itself, is a really powerful piece of a little bit of code to be able to do in using the Circuit Playground Express as an interface for things. If you're using it to increase or decrease brightness values on your NeoPixels, or change the pitch on a musical note coming out of the speaker, or whatever you want, being able to just take a number and add to it or subtract to it in that simple way, you'll use it all over the place. So that is the MakeCode Minute. Now, what I'd like to do is take this concept and show you how I'm using it in the project for today. So I'm gonna just put this block right back here. Let's see if that's in my face. No, I'm mostly out of my face now. I'm getting better at that. So decrementing. Thank you, Matumble. It's decrementing, not de-incrementing. So this project for today, I want to be able to use the A and B button to decrease or increase a timing for a strobe effect. So I'm going to flash lights, and I want to be able to make them flash faster or slower. And I also want to use the buttons for a second purpose in a second mode, and that's going to be to increase or decrease the speed of a motor that's spinning. And without going too much into the project right now, when you're tuning things for a stroboscopic effect, you can have something be constant and then just tune the flashes, so the motor spinning at a constant rate. But sometimes that won't give you exactly the effect you want, just because of the imprecisions of how we're going to build this, and it doesn't have feedback. So I wanted to be able to change the speed of the motor and change the speed of the strobe to try to tune it a little more to my liking. So the question is, how do you use only two buttons as an up and down for two different things? And so looking through the code here, what I do first is on the start, I'm just going to set all of the lights to white. All the NeoPixels on the Circuit Playground Express will be set to white. And then I have three variables here that I'm using. I'm using set the switch mode. So the little switch on the Circuit Playground Express, is that going to be to, there it is, the left or the right. And I'm using a Boolean here, so you can see this is equal to true. So it starts out as true, which I'm going to call left, and then when it's false, I'll call that right. Then I have two other variables. I have the strobe rate, which I'm setting to 3 milliseconds to begin with, and I have the motor speed, which I'm setting to 80%. In the case of the switches here, put that one on my forehead for emphasis, on the switch mode left, so that's an input that you can grab out of here. So on switch mode, move to the left, it's going to set the value of this switch mode variable to true. And when it's moved to the right, it's going to change that value and switch it over to false. So that's how I am changing this variable called switch mode. So the question is, how am I using that variable switch mode? And if we look down here at how I'm using the buttons, I have a on button down and an on for A and an on button down for B. And inside of them, they each have this if-else statement. So the condition that's tested is, if the switch mode is set to true, meaning it's left, then do one thing with the button. And if it's the opposite of that, then do a different thing. And so in the case of the switch being set to the left, what the button press does is it changes the strobe rate to increment by 0.5. So the same thing we just showed a second ago with that myFoo variable, except here I'm going and taking the strobe rate to strobe rate plus 0.5, or if I hit the other button, it goes strobe rate minus 0.5. That's when the switch is to the left. When the switch is to the right, then this condition is no longer true. This is false, and so this if-else statement will do whatever's in this second bracket. And inside of the second bracket, I have setting the motor speed to be whatever the motor speed is to begin with, minus 1. So initially we start at 80, so if I hit that button once with the mode of the switch over on the right, it will drop down to 79. And the button on the right, the B button, does increment it by 1, so it's going to go up to 81 if that was the first thing I did. So that is it. It's a pretty simple program, and I think it makes nice logical sense looking at it. So that's the kind of bonus minute today, is just looking at how we can use a switch to take us between two different modes, which helps us get the most out of the available pieces of user interface on the Circuit Playground Express. Now, you could certainly use 7 capacitive touchpads if you wanted to. There's a lot of possible UI without even adding buttons or switches. But I just wanted to use the 2 buttons in 2 different ways. So that is going to do it for our MakeCode Minute. So what I'd like to do now is, leading into our project, I want to take a look at a tool and technique. And this is going to be to build a precisely segmented disk, which is what we're going to be using for our zoetrope. So let's head over to the workbench, and I'm going to, you can see a preview of it right there. Oh, I'm going to turn off this air conditioner. Let's see, that'll make it a little less noisy. And of course, risk the chance that that camera overheats. So we'll see what happens. So what I've decided is I want to, for the zoetrope, I'm going to build a disk that has 6 objects on it. And these could be claymation figurines, these could be Lego figures, they could be 3D printed models. I think we're going to try it with ping pong balls today because it was quick and easy, and I built a little set of animations on animated faces on some ping pong balls with a marker. But what I want to do is precisely position these 6 objects around the perimeter of a disk so that as the disk is spinning and we flash light at it, we can try to get the stroboscopic effect in sync to the point where it looks like one object is in the front and it's animating. So the tool and tip of the day is getting yourself a precisely segmented, 6-segmented circle. So let me switch over to, oops, that view there. And I'm sure there are a bunch of different ways to do this, but I think this one is really, really handy. So what I'm going to start with is a compass. And the disk I want to make is about like so. And so what I'm going to do is actually, I'll go in the center actually. That'll make life a little easier. So I'm going to draw out my circle. Hopefully you can see that. I'm going to zoom the camera in here. Get this pretty dark. And there we go. So now what we can do to create 6 segments on here is take the point of the compass, and I'm going to set it on the circle anywhere on the perimeter of the circle. It doesn't really matter. So you don't have to do any measurement in particular to get it into a nice place. I'm going to place it kind of over here on the right, but it actually doesn't matter one bit. So by placing this compass here, and it still has the radius of the circle, all I need to do is create a mark right here. You'll see this explained sometimes as creating full circles. That's another way you can do it. So let's do it that way. But keep in mind, this one here is our circle that we're keeping, and the rest is just going to be guidelines for us. So now what I do is I simply move the point of the compass to the intersection of my original circle and my second circle, and do it again. So I'm going to go off the page a little bit there. A lot of this is unnecessary, right? We could just do the intersections, but I think it makes kind of a cool pattern and maybe makes it more gettable. Okay, moving around. I'm just going to move the paper. And the more precise you get that, the more exact everything will be. Okay, again, you can see I could not worry about these intersections because a lot of them are going to become redundant, but it sure looks cool. I have this book called Sacred Geometry that talks about building all kinds of incredible patterns that you see in Moorish temples and Persian tile work, and a lot of them have these incredible principles for creation. I did that one, and let's do this last one just to be complete. The points are all there already, but this will just give us these cool flower petal, 6 petal shapes in the center. So there you go. That is now a perfectly segmented 6-sided circle. I should say it's not segmented yet, but the intersection points here will lead me to all of the intersections that I need to create the segments themselves. Sorry, I'm distracted because I just wanted to pop up my chat for the YouTube, because I didn't have that one up. Hey, and now I'm going to hear an echo of myself. Hello. So now what I'll do is just take a pencil and connect the dots. You can try to get it pretty precise by placing your pencil in a point and then next to the ruler, and repeat up at the top. So there's one. Looks like C. Grover said in the chat, there's a reason that a compass is called a divider. I have never heard that. I didn't know that. My schooling is incomplete. And last one. Now, for our purposes, what I'd like to do is cut out this circle and maybe mount it to a thicker piece of cardboard as well. We'll see, we may or may not need that. But I also want to be able to place these ping pong balls at the exact position along this curve so they don't kind of move forward and backwards as we consider the different balls. I want them all in the same spot, and that spot is not the very edge here. So all I'm going to do is take my compass and create a smaller segment, and that can be, let's decide where we want to put the center of the ball. Yeah, let's see, should we have it not overhang? Let's have it not overhang. So I'm going to come in, say about to there. And now again, I could draw a circle, or I can just make a little mark here, and that's where those intersections will go for gluing down the ping pong balls. And last one. Okay, I'm going to reset my compass back out to the original diameter in case I want to cut a, whoops, my compass is falling apart. In case I want to cut a thicker piece of cardboard to place underneath it. That one won't need these bisections or segments. It'll just need to be the same size, or roughly so. So let's start by cutting this out. Let's see how stiff it is. So this is chipboard, by the way. This is just a nice piece of cardboard like you'd find on the back of a notepad. I don't know. I think this one was inside of a IKEA package of some kind that we got. Here's a previous one you can see I did where I just only did the necessary arcs and didn't draw the full circles, but that one looks cooler. So let's cut that out, and I will break one of my rules and use scissors just because it's here and it's easy, and these are not particularly special scissors to me. And so, you know, circle cutting with an X-Acto is a bit slower going. You kind of have to take your time with it, I find. Probably with this chipboard it'll be a little easier. Now, I'm not using this as a cam or anything like that. It actually does not have to be all that circular. We're not spinning it at incredible RPMs, so it's not, I'm not too worried about wobble. But if I had one of those fancy Cricut machines like the Ruiz brothers, or if I took the time to laser cut this, we could get super, super accurate stuff, which would be fun. But a lot of these projects can be done with a knife or scissors. Okay, so there we have our delightful little disc. And yeah, you know what? I think that seems pretty stable for our needs. So let's go ahead and I'm going to punch the center through just a little bit more, so I know where that hole is, so that I'll be able to mount it onto a motor mount. So that's the tip of the day, and I think that'll lead nicely into talking about the project today. So the project is, I'm going to step away from these materials and this design for a second, and I'm going to show you kind of one of the inspirations. So look up 3D zoetrope, three-dimensional zoetrope, Pixar, and you'll find a really beautiful example, if you haven't seen it before, of a large-scale, multi-disc, multi-level zoetrope of a bunch of different Pixar characters like Jessie and Woody from Toy Story and the little aliens jumping around. And, what was done was they created 3D models based on 3D animation cycles. So they might have a second of animation, and it might actually be 24 frames a second, I'm not sure. So there may be 24 models, or maybe there's 48 models on the outer ring. of a character running, let's say. So each frame of the run cycle has been attached to this disk, and then it's spun up to speed, and a synchronized strobe light starts flashing, and all of a sudden what looks like just a blur turns into these characters sort of locked in space going through their animations. So that's one inspiration. The other inspiration, I'm going to try to demo this because it'll help us get our setup working for showing stuff strobing in the dark, and that is this incredibly cool toy that I got at Disneyland a few years ago, maybe 8, 9 years ago. It's called Disney Vision, and it's this retro-looking television set, television cabinet thing, and it has an on-off switch, it has a set of 4 batteries, and it has 2 control knobs. And when you turn it on, what happens is there's a motor that has, let me zoom in a little bit here more. It has a motor that will spin this, eccentrically spin and vibrate this little stalk, which causes a rubbery character. In this case, it's the Hatbox Ghost, and he's missing a hand. And it came with maybe 8 different characters, so you could put on a Mickey Mouse on there, or the Hatbox Ghost, or a Woody from Toy Story. When that shakes, the character, you can see, jiggles all around. Oh, let me get that into the camera. And we'll get a close-up here in a second. With this jiggling all around, it just kind of looks like a mess until you tune in the strobe light. There's a bright LED. I think there's 3 LEDs up in the top. There's some in the bottom. Yeah, there's 6 LEDs total, looks like. And those are flashing, and you've got this little potentiometer where you can change the rate. When you lock it into a rate where the stroboscopic effect begins to happen with a sympathetic, repetitive part of this cycle, all of a sudden the character will come to life and have this much, much slower motion. It's like really doing this, but we're just getting that sort of wagon wheel effect of only seeing some of the motion snapshots. So enough talk. Let me get I have a cardboard box that I set up to be a little light blocking stage for us. So this is a big Amazon box, and then I have a black folded bit of cardboard inside there to cut the light down. Oops, like that. So what I'm going to do is set this right here. I thought I was going to need that square to make my segments, but no, I didn't. The compass is all it took. All right, so what we'll do is set, oh, my camera just went kaput on us. That's okay, we're going to switch to, let's go to this camera for a second. Excuse me, and in the corner, I'll place this little view here. Brent, you said no signal. Hopefully it's just that one camera went down, but you still got a me. I'm going to turn the AC back on. Obviously that camera couldn't handle it. Let me know if I'm still coming through. I think I am. All right. So I'm going to do is take my, I know you can't see me, but I'm going to take my little stroboscopic toy here. I'm going to place it inside the box. And I'm going to switch this down shooter over here. Okay, and what I'm going to do is I'm going to place a steady light source in there. So I have a little video LED panel light that I'll set in here so that you can see the before and after of having a steady light versus the strobe. And I just want to, there we go, get that box level. Okay, so, yeah, sorry, the inside of his little theater is black plastic. It ought to be matte finish. That would be a little better. And let me try to do a little focus on that. All right, now let's zoom this one up full screen. Get a little closer. Okay, so what I'll do is I'm going to turn it on, and you can see the guy starts shaking all over, and I can tune his speed. Okay, and what I'm going to do now is turn off this light, and now you're just going to see the strobe version. Oops, there we go. So now you see that strobing version, and I will start tuning the LED flashing. I'm going to try to see if I can get it to sync and do something cool to the naked eye, and then we'll see if it's possible to get that on video. There we go. So there you see he's sort of like doing this hitchhiking motion. It's a little harder to see on the camera than in real life, but it's pretty good. I'm going to tune his motor speed again. If I get something really cool locked in, let's see. Yeah, that's about as good as I'm getting it right now. So, but you can see, here's the idea. Now, what I'm going to do is turn this main light back on, and you'll see the reality of what's happening is chaos. Right, so he's shaking all around like crazy. It's a blur. But with the strobe, you start to get a much nicer effect. It's not perfect on video, and I'm not actually getting it tuned in as well as I would like. Let me try again. All right. So I think that's probably as good as we're going to get it. There we go. There's a nice one. So he's doing, you can see he's got this little reciprocating kind of motion. It's all locked in pretty nice. There he's almost standing still. So, you know, there's some slight out of phase stuff happening between the strobing and the motor and his cycle of motion. But again, look what's really happening here. It's just, it doesn't look like anything to the naked eye. But once we get that strobe on there, we get this really cool effect. Also, the lights being a little bit bluish, the LEDs in there helps with that sort of Halloween-y, ghosty effect, which I think is pretty cool. So I've often dreamt of building a huge one of these for a Halloween effect. So ever since I got it, I was like, man, if you got like a really big, like, built a mannequin or something and put some loose joints in there and shook the heck out of the thing with like a big butt shaker and had a strobe light on your porch, you could probably do something like this. I don't know. So this was the other inspiration. Besides the Disney Zoetrope, I was inspired by this. So let me try to fix my camera here that went out real quick due to the heat. Oh, I should have turned it off. Oh, you know what? I don't have the little screen popped out because I took it out and was using it for something else, and that does help keep the sensor cooler, I think. So we'll see if that comes back up. There we go. Okay, that'll at least help with the build a little bit. So I'm going to switch back to workshop view there, and yeah, we'll keep the ghost cam up. Okay, so let's set this thing aside and take a look at how we're going to build the Zoetrope using the Crickit and Circuit Playground Express and that MakeCode that we looked at earlier. Hey Donald, I see Donald, aka Maker Project Lab, is over in the YouTube chat. Nice to see you. If you guys don't, if everyone here in the different chats doesn't know about our good friend Donald Bell, who has Maker Project Lab as a weekly Maker update video, it encapsulates all kinds of cool stuff that's going on in the Maker world. It's a fantastic, he said woo. Hey Donald, it's fantastic sort of weekly digest of what's going on in making, as well as cool projects that Donald makes, and really good tool reviews. I think Noe and Pedro and I have all gotten 3 or 4 different things that Donald has recommended tool-wise over the last year or two. Okay, so let me set this here for a second. In fact, I'm going to switch to, let's go there, and yeah, there. You can zoom this out a little bit. Donald, I don't know if you've watched my show before, but there's a lot of camera management going on all the time, so get used to that. I'm always trying to find the right views of things. So we've created our disk, and I'm going to take a little stand here, a little pan of ice stand, and I've put on this move this so you can see it a little better. I've got the pan of ice stand with these little helping hand arms, and so on the helping hand arms I've got my Circuit Playground Express with the Crickit positioned here so that I'll be able to drive the motor from the Circuit Playground, or from the Crickit rather, and I'll be able to flash the lights of the Circuit Playground Express as the strobe that's going to hit our subjects. So now I kind of prototyped one of these earlier, but did it a little sloppy. So now that I've got the nicely segmented circle, we're going to switch over to that. So what? Oh, Tools and Techniques is on. Let me turn that off. Has that been on the whole time? No. I don't think it is. Yeah, I guess it has. Sorry about that. How did I not notice that till now? I got to make smaller banners. So I'm taking one of these little pulley wheels for the TT motors, and I'll zoom in nice and close here. The TT motors have a little flatted shaft. That little white piece right there is a cylinder with two flatted sides, and it also has a little hole in the center that you can screw down a screw. So it's a little different than the spline type of shaft you'll see on a servo motor. And this little pulley wheel is useful for using as a pulley, but also just as an attachment mount. So it fits over the little flatted shaft here, and the screw can go down in it, but it has a collection of 8 holes around it that we're going to use to attach to our disk. So first thing I want to do is get the disk attached to the pulley wheel and fairly well centered so that things don't wobble on us. This screwdriver is magnetic, so it likes to grab other screws. Stay right there. So this side goes down on the motor, so this top side I want to connect under the bottom here to our disk. So I punched a little hole in my disk, so I'm going to put the shaft screw through here and run it into the pulley just temporarily. I don't know if the screw is long enough to actually work in the long run, but that'll at least give me a center position so that I can add other connection. This could be hot glue, which is pretty tempting because I've got it right there in place. It could be some other screws. You know, I'm going to just use hot glue because I don't need this to come apart easily. So I'm just going to squirt it right up underneath there. By the way, did you notice I rebranded my hot glue gun here? It's a Sure Bonder, but now it's a John Park Workshop Sure Bonder. Okay, so I've got a nice bead of hot glue in there. Oh yeah, there we go. So Europe says 118 days to Halloween, plenty of time for the life-size version. This is very true. It's nice to think of it early for a change. Okay, so we're going to let that cool. And you can see, if I come up real close here, that screw actually is going to bite about a turn and a half or 2 turns down into the shaft, which may be enough. So I will try to, since this cardboard's nice and thin, it ought to work as planned and connect to our TT motor. So while that cools, let's take a look at our ping pong balls. So what I've done is I just took some ping pong balls and drew faces on them. And I didn't do a super precise job, but what my goal was to keep the eyes and mouth roughly in the same position on them so they don't look like they're moving up and down. And I built a progression of 6 of these faces. So I think I go from these are not going to stay, but I'm going to go from a small mouth to a small beginning of a smile. So here we go. So mouth to a little bit of a smile to a bigger smile to a full grin to a wide O to a small ooh, and then back down to the mm. So there's our 6 frames of animation. And all we need to do is now glue those down onto the spots on our ball, all facing out, so that they will face the viewer when this spins around. So what I'll do is, I was going to try to take this thing for a spin on the motor, but let's not. Let's just go for attaching the balls. So I will start with the small neutral mouth, that guy. And I'm just going to hit it with a... So I tried this before, and so I've got a little bit of hot glue and cardboard on there already. I think I'm just going to leave that and not try to chip it off. So a little bead of hot glue. Set that down. Like so. Okay, let me switch cameras so you get a little bigger view of that. Nope, not that big. Really, I really should label these. I mean, how long have I been doing this wrong now? I never think to label them. Okay, so from small mouth to small smile, small neutral to small smile. Another project really inspiring for this, especially when I thought to do it with ping pong balls, is when I worked at Disney Research, there was a research scientist there named Lanny Smoot, who's a prolific inventor, creates unbelievably cool stuff. And he had created a zoetrope that had voice recognition, sort of. So it was a disc of ping pong balls with faces on them to start with, and then later they tried some 3D printed models. And it spun really fast. And then there was some software which adjusted the timing of the strobe light to place different, essentially make it seem like different mouth shapes were in front of you that were being called up by voice. So you could speak up into a microphone and go like, hey, how's it going? And you'd see this little ping pong ball say, hey, how's it going? Because the precision of the strobing was so good, and there were optical encoders and some very clever software involved with making sure that it strobed what you would need to strobe to see the correct mouth positions. It was unbelievable. And I think they took that one on the road. I saw it at SIGGRAPH 1 year, or E3 1 year. If any of you know Daniel Reitz, he's a good friend of the maker community from years back. Daniel ended up working with Lanny on that project. But look up, yeah, Disney Research ping pong ball zoetrope. That ought to find you something. This one, alas, is not going to be as complicated. The effect won't be quite as impressive because we're not going to use optical encoders, so we don't have a precise, this is a DC motor that's not super precise, so we won't know exactly where things are, and we're not getting feedback. But our hope is at least to get some strobing to lock in a ball that we can see this run through this cycle of face animations. So let's drop this onto here. I'm going to set my little pulley motor onto, I unscrew that screw a little bit. So it will drop on and lock in place if you get it right. There we go. And now we can screw that down. There's a little bit of wobble to the shaft of this, so it would be nice to get a bearing of some kind that would hold it in place. But I think this is a good time to switch cameras to that one. How about? Let's see if we can get that focused in. And flipped to the right direction. There we go. So I'm going to focus that. Okay, so here is... It's obviously super bright, so we're not going to get any of the strobe effect right now. And in fact, I'm just going to cover this so it doesn't cheat at all. So I'm going to turn on my... Okay, so there we go. There's our spinning. That's good. They didn't go flying off. So I guess I let the glue cool enough. So now what we're going to do is we're going to... Let me actually show you the button incrementing and decrementing. Thank you. Was that Matambale who corrected me on that? Decrementing. TrueTech, a 3D bearing mount for that would be awesome. Yeah, this was... Actually, I didn't look. I bet you there's some good Zoetrope projects on online that you can download from places like Thingiverse. Let me get that straight. So what I'm going to do now is I'm going to turn it back on, and I'm going to use the buttons to change the speed. So it's changing 1% of a 0 to 100% motor speed each time I decrement or increment. So let's, it starts at 100, so I'm going to slow it down. So I'm going to turn this on, and now I have to flip my switch to the right so that its A and B buttons are used for motor. And you can hear it probably more than you can see it because it's pretty blurred on camera. But that is now running quite a bit slower. There we go. All right. You can almost pretend like you're seeing an animation. Now I'll hit the other button and speed it back up. Okay, so that's and then you can also see I've got the strobe. So I've just switched my switch over so that the buttons are now controlling the strobe. So the neopixels are blinking. These do not capture on camera at all. The refresh rate of the camera, you can't see it, but these are like... Oh, that one's actually... I kind of locked it in at a rate where you can see it. But if I change it much, you'll start to probably see it look like it's not blinking. I think I slowed it down enough to... Yeah, if I get it going as fast as it really needs to be, it kind of looks like it's not doing anything. Or, yeah, so that's actually blinking faster than it was before, but you won't see that. But the cool thing is we're going to put this inside of the dark theater box and try it out. You should see the effect a lot better than just looking at the bare LEDs. So let's take that little magical theater here, and I'll just reposition the little, these helping hands and pan devices. Boy, they're helpful for these kinds of figuring things out because everything's adjustable in a pretty good way. So what I'll do is I'll get my panel light here so that you can see how things are set up before we try to get the effect. And sorry for flipping your world upside down. And sideways. There we go. Okay, so I will try to cut some of the room light as well. I'm going to turn it on, and then I will try adjusting the strobing effect to see what we can get. So I'm turning on the Crickit. Come on, Crickit. Where's your switch? I'm upside down, aren't I? Hey. Okay. Okay, so I'm going to turn off the big light. Oh, you can already see we're getting sort of a... Yeah, so check that out. So here's the lights on. You can see the blur goes away. Okay, so I'm going to close this down a little bit to cut the light, and then I will adjust. There we go. Getting there. So it's probably twice as apparent in real life than it is over video, but I think you can see it well enough to at least get the idea. I'm going to keep adjusting the strobe speed to see if we can lock it in any better. That's not bad. And as I get my fingers out of the way, it being brighter is helpful, I think. So I think as this, yeah, so this is flashing pretty slow. It's so slow that you're getting a lot of blur on their faces. So I'm going to go the other way and get the strobe to be a faster strobe. There we go. Okay, so now I'm going to switch this to the speed control and just see if I can lock it in any better by slowing it down. I can't go faster. Oh, I can actually. I started at 80%, so let's see. All right, I'm going to get it up to, oh, that was nice. Okay, let me go back to the strobe now. Let's give this guy some dialogue. Oh, that was pretty good there for a moment. Yeah, I'm looking at my monitor to see how you guys are seeing it. Yeah, I don't know if I'll get it any better than that. I'm going to try back on the speed just for a second. And another thing is that I am changing the increment I set for these. It might be that I want to have smaller increments. I might want to have finer grained control to get it to stop moving as much. But there you go. I think that's a pretty decent zoetrope for using a Crickit, a DC motor, TT motor, and the NeoPixel lights. If you try this at home, I'm going to create a guide for this, and I'll probably fine-tune some of the settings for giving you smaller increments for at least the flashing, so that if you can really fine-tune it. Yeah, this one every once in a while really locks in. If you watch it, I'll watch this video again later. Yes, for a moment there, the phasing is just right that I see a ball just sort of sitting still and talking, which is cool. All right, so let's turn that off. Oh, and a reminder, let's pop the big light on again. This is what's really happening in the real world. It's a blur, but then our strobe lets us see our little happy friend, the ping pong ball. And you can imagine that if you get a larger disc, so long as the motor can turn it, you'd be able to, go to that camera view, you'd be able to create a denser animation with more balls on there. Everything is going to be relative, of course, the size and speed and the rate at which you can blink. And I actually don't know what the theoretical or what the practical limit is of blinking the NeoPixels, but the way that I tried this was on Lady Ada's recommendation by using brightness. So you'll notice I'm not turning NeoPixels off and NeoPixels on because that is going to take longer for the Circuit Playground Express to actually communicate to them versus the brightness control. That one just happens to be faster in this case. That was her recommendation. You may be able to get faster blinks using Circuit Playground, Circuit Python or Arduino versus MakeCode, but this worked well enough in MakeCode that I thought it was worth showing, and then I'll experiment with this a little bit over the next few days as I prepare a guide for you to make your own zoetrope. And you can also imagine this doesn't have to be ping pong balls. You could do hand-drawn animations that are spinning in front of you like a more traditional disc zoetrope, but instead of using slits to blink, you're using a strobe. You could use, like I said, any little Lego figures, minifigs, or 3D prints would be awesome. Even wire, you could use, you know, pipe cleaners to create a little wire shape doing some sort of an animation. So, oh wow, Donald, thank you. Donald says he's unreasonably excited about this project. Yeah, the NeoPixels as a strobe, I kind of didn't know what to think, but they blink fast enough, and boy, they're bright. You know, there's 10 of them, so it's, you know, a lot of times the thing with this is you want it to be very dark setting and then very bright when it hits it. But it's pretty darn good, and I would love to hear how people do trying out their own variations on this, see if you can refine it. So like C. Grover said we've got 100 and some days, isn't it, until Halloween? What was it, 108 days? Let's get on it. Oh, this isn't scrolling for me very well. So, okay, so let's head back on over to Workbench. I'm going to turn off that AC again, and if the camera dies, that's okay. I'm not in front of it anymore. Let's not forget 10% off in the store today. Coupon code Strobe. And I just want to thank you all so much for coming out and for participating in the chats and going on the journey with me here today and building our stroboscopic zoetrope. I hope you had fun because I sure did. And I will be hanging out over in the Discord chat for a little bit if anyone has more comments, thoughts, puns, jokes, suggestions, requests, and so on. But that's all I got for the broadcast. So for Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you next week.